Alright, so in this video we're going to learn about exponential regression. And when we do regression problems, the first thing we have to make sure to do is to turn the diagnostic on so we can see the correlation coefficient, okay? So in your calculator, the first thing you need to do is press the second button, the 0 button, and then x -1, okay? That's the easiest and quickest way to get down all the way to diagnostic on, and hit enter, enter, okay? So again, to turn diagnostic on, it's second 0, and then this x -1 button. Okay, so now I can start to do my regression. So let's take a look at our first problem, which is about growth. Okay, so your family is planning on moving across the country to the city of Las Vegas, and the tables on this sheet show some historic stats about Vegas that were gathered through online resources. Your parents are wondering if it's possible to use this data to make some predictions about the future of Las Vegas. So I've got a year starting at 1990 and going all the way to 2005. And then I've got the population of Vegas going all the way up to a large number, okay? So the first thing I need to do is on my calculator create a scatter plot with this year and population data. So when looking at the year, you do not type in 1990. So what you do is 1990 was your starting year. So that's going to be your year 0, okay? And then you count how many years happened after 1990. So for example, 1992 is 2 years after 1990. And then 1994 would be 4 years, 6 years, 8 years, 9 years. And then 2000 will be 10 years after 1990. So then 2002 would be 12 years. And then 2015 would be 15 years after, okay? So now I can type this in under the stat function so I can get an equation. So you're going to hit stat and then edit, okay? So again, these are your L1 columns, and you're going to type in the numbers 0 through 15 into L1, and then you're going to type these numbers into the L2 column, okay? So take a moment and press pause and type those numbers into L1 and L2, and then you can rejoin this, okay? So press pause. So once you have typed all those numbers into L1 and L2, to get the equation, you're going to press the stat button again, and you're going to go over to calculate. Previously, we've done linear regression, so we pressed 4, but now we're doing exponential, so we need to keep scrolling until we see something like exponential, which would be 0, okay? So instead of pressing 4, you're going to press 0 from now on. Okay, again, your calculator, you got to go all the way down to calculate. But once you hit enter, you should get A as 99,859, and then your B value be 1.15, okay? So again, notice it's y equals A times B to the x. So we're going to write our equation like that. So for number 2, it says describe which type of regression will be best. So the best type of regression would be exponential. So we're going to be doing exponential regression, and write its equation using function notation. So again, function notation is f of x equals, and then your equation. So my A value was 99859. We can't have 0.3 of a person, so we're going to leave it like that. And then my B value was 1.15. So 1.15, raise it to the x power. So this growth factor makes sense because it's bigger than 1, and this was a growth problem, okay? So that's a good sign. What's the correlation coefficient? So again, in the past we have used r, but we're going to focus on r squared from now on. So r squared is your correlation coefficient, and it was 0.999, okay? That's very good because it's close to 1. So what does it tell you about the data? The data is very accurate. Okay, so that means I can use this equation for future years to predict the population, and it'd be very, very accurate. Okay. Number 4, explain what the numbers in your equation mean in the context of the problem. So I need to talk about this number and this number. So that 99 859 is my initial value, and the initial value in the problem is the population at my starting year, which was 1990. So that number is going to mean the population in 1990, which is really close to what it actually should have been, which was 100,000, okay? The next thing is this factor. So it's kind of tricky what you do with this number. So that is our factor. You have to find the rate, okay? So again, the rate is 1 minus 1 from that number. So 1.15 minus 1 is going to be 0.15. Again, I like to turn it into a percent. So that's the same as 15%. So this population is increasing by 15% every single year, okay? So you could say for every year, the population is increasing by 15%. Okay. So when you talk about this growth factor, you have to find the rate first. And then again, you make it a percent. And then that's the percent that it's increasing or decreasing by. Okay. Number 5 says use your regression equation to predict the population for 2016. So I'm going to use this equation that we found up here. So 99859, 1.15. But I need to plug in a number up here for my x value. Okay, and you're not going to plug in 2016, okay, because our starting year was 1990. So you have to see how many years passed from 1990 to 2016. So to do that, I'm going to do 2016, subtract 1990, or you can do some mental math and know that 26 years have passed from 1990 to 2016. So I'm going to plug in 26 for my x value. Okay, so let's see what that value is. So 99859 times 1.15. I'm going to raise it to the 26. So that's a lot of people. So 3780341. So that's going to be 3 million people in 2016 living in Los Angeles. Okay. Whoop. Sorry about that. All right. Last question says, when is the population going to reach 2 million people? Okay. So I kind of need to guess around with some numbers to see when this is going to go over 2 million. I know it's already at 3 million, so I know it's got to be less than 26. So let me guess 1.15. Let me plug in 21. Okay, not 2 million yet. We're still at 1 million. So let me plug in another number. Let's plug in 22 and see if we get 2 million. Yay, we got it. Okay. So that means in 22 years, the population is going to reach 2 million people. So let's figure out actually what year that is. So we're starting off in 1990, and I'm going to add 22 years, and let's see what year it is. So we started off in 1990, and after 22 years, it would be the year 2012. So we could say in 2012, the population will reach 2 million. Cool. Exponentials are awesome. Okay. All right, let's talk about decay now. So turn it over. So here is some problems on exponential decay. So again, we've got the same amount of years that we had before, but now we're going to be talking about crimes happening per year. So I noticed that those numbers are going down, so it's probably going to be decay. okay? But we need to type that in our calculator to get an equation. So again, to do it, you're going to press Stat and Edit, and luckily you don't have to change this L1 column because these are still the same, but you do need to clear out that L2 column and then type in these numbers. So go ahead and type in the crimes into L2 and then find the equation and write it under number 2. So press pause. Alright, so you should have typed all of the crimes into L2. Again, you're going to press the Stat button, go over to Calculate, and scroll all the way down to 0, or just press 0 for exponential regression, and you should have gotten this for your answer. If you did not, please let me know and I can come help you. But your equation is going to be y equals 13,972. And then your b value was going to be 0.83. And raise it to the x, okay? So again, this makes sense because this is a decay problem, and this number is going to be smaller than 1. All right. Next thing says, what's the correlation coefficient, and what does it tell you about the data? So again, ignore r. R squared is going to be 0.999. Which is very, very close to 1, so that means the data is accurate. You could say it's very strong, very accurate. So that means I can use this equation to predict some future events. Next question. Explain what the numbers in your equation mean in the context of the problem. So again, I need to talk about this number. I need to talk about the factors. So the 13,972 is my starting point. So what that means is in 1990, there was about 13,000 crimes, which is actually really close. So in 1990, there were 13,972 crimes. Okay, which is very accurate to that table up there. And then I need to talk about this 0.83. So again, that's the factor, and you have to find the rate. So to find the rate, you need to see how far it is away from 1. So I need to do 1 minus 0.83 to get 0.17. Okay, and then that means I need to make it a decimal, or a percent, which would be 17%. So something is happening by 7% every single year. So that means our crimes are going down by 17% every year. Okay, so for every year, the crimes are decreasing by 17%. Okay. All right. Last question. Use your regression equation to predict how many crimes there are going to be in 2023. So you're not going to plug in 2023 into your equation. You need to figure out how much time has passed from 1990 to 2023. Okay. So to do that, you're going to do 2023 and subtract the year 1990. So that means 33 years have passed between that, okay? So I'm going to plug in 33 into my equation for my x value, and then let's see what we get. So 13,972.83, and then raise it to the 33, okay? So I'm going to get 29.8, so that's about 30. So 30 crimes are going to happen in the year 2023. So that's good. Only 30 crimes. Okay. All right. So that is how you do exponential regression in the calculator. If you have any questions, let me know. But now it's time to practice. Thanks for watching.